Craig just mentioned in Twitter that I should just put the Hotmarts around the amplitude display to see what's going on from another perspective, which I think that's, I don't know if that's going to be super helpful, but I think because the reason I just started recording now is because I think that this might, it just gave me an idea actually. I think it just gave me an idea. But I gotta check that. So okay, so that kind of makes, okay. So this is this, and then I'm now gonna do a Hotmars. I should use a mouse because I'm using my trackpad and I cannot easily then. It's a bit slow, but to place all the gates. No, after the Hotmars. I mean, in this case, I don't care so much because this would just make sure that the rest of the circuit works well, right? Because I mean, this is the idea: you put hardware around so they just cancel each other in the end. That's, I think I was expecting that. I was expecting, because at the end of the day, what this is then doing is just doing an X gate to all the qubits, right? Because the all no, sorry, not an X gate. Mistake. It's phasing. It's phasing. So, because what I'm trying to do is I'm trying to find from an using that using the definition of this operation, find sort of an analogous like an analogous definition of this one. So, and the way I understand this one is that the, and I'm going to assume we are in superposition. So the state that matches these combinations, so 1 1 0 1 1, is phased, and that's really what happens here. And so I'm trying to find a different a similar kind of explanation, like for something that matches these, then it's phased, because I think that's the, I mean, that's also the way that Craig puts it in the blog post. Is like it negates the axis and the axis, or it phases the axis. And if I put the Hotmarts around, that's really what I'm seeing here, right? I'm seeing one, like the state where it's all ones gets phased. Nothing else changes. The actual magnitude is the same, and then everything else is the same. Everything else, yeah. Everything else is the same. Okay. Which then, because the problem that I had understanding, like if I remove those now, I'll remove those. So the problem that I had was that I could not figure out, because I think I was close to that, but I was kind of saying, okay, so the for this for the because for this is easy, because here it's easy because we are on the z-axis, so it's like zeros. So this is really the axis that defines the 0, the 1. But here is the x-axis is the axis that defines the plus state and the minus state. So I was kind of like, how can you? It's not, you cannot easily say from all the different possible states, the ones that match exactly like plus 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 plus. You can't say that, because you're not defining those states in function of, as a function of the plus basis, because that's not your basis. The basis is the z base, like the one you're using is the z basis. So I was kind of, and I just kind of think now, if what you're doing is just want to try. So let's say you're, yeah. So let's say 3 ones, and then the Hadamard, right? So this is plus, minus, minus, right? Plus, minus, plus, plus, minus. Because if what you're doing is you're negating the 111 from the using x as your basis, the computational basis, not the z but the x. Like that's really what we just saw by putting the Hadamard gates is we saw the whole the system from the using the x-axis as a computational basis. So if that's what's happening, then if I stay here, because what I'm trying to define is I'm trying to understand, I'm trying to see if I can intuitively define that operation, seeing it from the z axis, not from the x axis. But maybe that's just stupid. I don't know. But um, let me just get those guys out of the picture here. And so ideally, what this would do is would flip. So what maybe what this does is it flips the phase for those states which would be part of 111 from an x from a computational basis x kind of, which in turn means that if we've got here 6, right, what we're now, yeah, actually, because of course, because that is indeed 11111, right? We just went now to when you apply the Hanamarts here, you're actually going to the you're going to that uniform superposition, which if here we would change basically our computational basis to be the x-axis, then we would have actually the state 1 1 1 1 1, like all ones. So what it's kind of doing, okay, so I like that because okay, it's kind of I can see that as a filter kind of thing, because it's the same way that I used to see that, right? So you see that as a filter, where it's like you have your superposition, and then it kind of it flags that one thing, right? Which is this one here. So what what this would do is it flags not just the one element, but it flags like everything that has this pattern, right? Because this is the entire 1 1 1 1 1 1 in the x basis, and so it flips all that stuff. But this one then doesn't match, so it doesn't flip it. So it doesn't flip it, but it's still, I can't explain why there's an increase in amplitude from that perspective. Doesn't flip it. Because I like to think that, so this is this, right? 1 1 0 1 1, and this is this 0 1 0 0. Because actually, uh, look. If I would now apply next gate to all of those, right, it would be 1 1 1 1 1 1, right? Which, but remember, without changing the phase, so the phase would be 0, and that's what we have here. Bam. Now that explains. I hope so. Wait a second. That I think that explains why the reason of the amplitude here. So that is just like a negate. So if I see that as, if I really see that from a Z perspective, from a computational basis Z, I really understand that as I'm going to negate everything, right? So this here becomes this here because exactly that's this. Let's check. This here would be would be this here. And so the problem is because yeah, of course, look. Uh, or not. Uh, I feel I'm on the right path because these. Uh, so you would not, because this would become 11011, right? And which you would not negate in here. And you would not negate this one because it doesn't belong to that. It doesn't match, right? So what it would just do is it would add up because you would have that twice, this and this. So you would get this. Minus 0.5. So this is but why is then where is then this one coming from? Where is this one coming from? Because if you see these, as applying those negations, it kind of makes sense. Because for example, like, again, like I don't know, just pick this one. It's 3 zeros and 2 ones, and this just becomes this one, right? But because you messed up here, the phase, this one would become 00100, but with the phase in this direction, and then this will become 00100, not 11011. But this doesn't get flipped because you only apply the negation to the stuff that matches here, to that whole state. But still that doesn't answer why there is still any amplitude in here at all. Because where does this come from then, if you're not negating this one? But I think I'm on the right path intuitively. And then you do the same, right? Then you flip things, and then you're here, right? And again, these ones, they have, instead of having the opposite, but I thought I had tried that explanation at smaller scale and it somehow didn't work. Because if I'm like that, right, I put the amplitudes here, and now I say, zero, okay, yeah, and now I say, okay, no, but that's correct, yeah. And now I want to say I want the flag 0, 1 or 1, 1, right? 1 1. So I do that, and now I've changed this, and now when I add this, so what's happening here is, so what I'm saying is I want to negate this. So but now this actually look like the opposite. So if I negate this one, 0 1 0 becomes 0 1, here becomes 0 1. Why does this, why? Because here it's extreme, because it all ends up with 1 1, literally. Well, yeah. Well, yeah, because these matches, so those two get negated. That doesn't make sense either. Doesn't make sense either. No. Gotta try again. Kinda doesn't make sense. Yeah, we'll see. We'll see. Kind of felt I was in the right direction, but it's not really good.